Planets are often imagined as calm, predictable worlds orbiting their stars in neat paths, much like Earth does around the Sun. But as astronomers have explored deeper into the universe, they have discovered that many planets are anything but ordinary. In fact, some of them are so extreme that they seem to break the very rules of science we once thought were universal. These strange worlds challenge our understanding of physics, chemistry, and planetary formation, revealing that the universe is far more bizarre than we ever imagined. One of the most astonishing types of planets is the so-called hot Jupiters. These are massive gas giants, similar in size to Jupiter, but they orbit incredibly close to their stars, sometimes closer than Mercury is to the Sun. Because of this, their surface temperatures can reach thousands of degrees Celsius, hot enough to melt metals. Some of these planets even have atmospheres filled with vaporized iron or silicon, creating clouds made of molten rock. The idea that a planet can have a surface made entirely of liquid rock challenges our understanding of what a planet should look like. Another category of extreme worlds includes rogue planets, planets that do not orbit any star at all. These lonely wanderers drift through the cold darkness of interstellar space, having been ejected from their original systems by gravitational interactions. Without a star to provide heat and light, these planets should be completely frozen and lifeless. However, some scientists believe that if a rogue planet has a thick enough atmosphere, it could trap internal heat and maintain subsurface oceans of liquid water. This raises the incredible possibility that life could exist on a planet with no sun, surviving in total darkness beneath layers of ice. Such a concept goes far beyond traditional ideas of habitable zones and challenges the assumption that life requires sunlight to exist. Equally fascinating are planets with extreme densities and compositions. Some exoplanets are believed to be made largely of diamond. These diamond planets form under conditions where carbon is subjected to immense pressure, causing it to crystallize into diamond structures on a planetary scale. Imagine an entire world glittering like a giant gemstone. This is not science fiction, but a real possibility supported by observations. On the other end of the spectrum, there are superpuff planets, which are incredibly low in density. These planets can be as large as Jupiter, but have only a fraction of its mass, making them as light as cotton candy in comparison. Their atmospheres are so extended and thin that they barely hold together, defying expectations about how planets maintain their structure. Some planets also challenge our understanding of orbital mechanics. There are worlds that orbit their stars in extremely elliptical paths, swinging from scorching heat to freezing cold over the course of a single year. Others are tidally locked, meaning one side of the planet always faces the star, while the other side remains in permanent darkness. This creates extreme temperature differences between the two regions, known as the terminator line, which may be the only place where conditions are somewhat stable. In such environments, weather systems would be unlike anything on Earth, with massive storms constantly moving heat from one side of the planet to the other. Perhaps even more mind-bending are planets that orbit not one, but two stars. These circumbinary planets experience complex gravitational forces and shifting patterns of light and darkness. From the surface of such a world, you might see two suns rising and setting in the sky, creating a constantly changing environment. This was once considered highly unlikely, but multiple examples have now been discovered, proving that planetary systems can be far more diverse than our own solar system. There are also planets with extreme magnetic fields and radiation levels. Some orbit very active stars that constantly emit powerful flares and bursts of radiation. These planets are bombarded with energy that would strip away atmospheres and destroy any known form of life. Yet some manage to retain their atmospheres, suggesting that they have protective magnetic fields far stronger than Earth's. Understanding how these planets survive such harsh conditions could provide new insights into planetary protection and the potential for life in extreme environments. Finally, there are planets that seem to exist on the edge of what is physically possible. Some are so close to their stars that they are being slowly torn apart by tidal forces, leaving trails of material behind them, like cosmic comets. Others are so massive that they blur the line between planets and stars, challenging the very definition of what a planet is. Each of these discoveries pushes the boundaries of science, forcing researchers to revise theories and explore new ideas. In the end, these extreme planets remind us that the universe does not always follow the rules we expect. What once seemed impossible is now being observed with increasing frequency, showing that nature is far more creative and unpredictable than we ever imagined. As technology advances and more powerful telescopes are developed, we will likely discover even stranger worlds, planets that defy logic, challenge physics, and expand our understanding of reality itself. The study of these bizarre worlds is not just about curiosity, it's about redefining what is possible and recognizing that our place in the universe is part of a much larger, more mysterious story.